Welcome back, everybody. 5.3, we're going to get into solving problems with trigonometry. Okay, so as in solving story problems with trig. And this section is going to build off of some of the problem solving we did earlier in the semester. Okay, we'll think of this as kind of the advanced problem solving. Part 1, we've got two types of questions for you. Let's get going with those. All right, in problem 1, we're going to look at finding angles with trig. Okay, part A says a 20-foot tall flagpole casts a 14.5-foot shadow. To the nearest degree, find the angle of elevation from the ground to the sun. Okay, so let's draw this up. We've got a flagpole that is 20 feet tall. And we're going to say it casts a 14.5-foot long shadow. Okay, and then to the nearest degree, find the angle of elevation from the ground to the sun. Okay, well, what does this have to do with the sun? Well, where that shadow's coming from is from the sun here. And basically, the sun's rays are going to go from the top of whatever we're looking at to the edge of its shadow. This is the angle we want to know about. Okay, this angle of elevation here. And to solve that, I'm going to use this right triangle here with kind of the tip of the flagpole to the top, to the end of the shadow, with the shadow and this X. Okay, to solve that now, like we said, I'm going to use trigonometry. We've got our angle X, and the 20 is the opposite side of the X. The 14.5 is the adjacent side. So opposite adjacent, I'm going to use my tangent ratio. We're going to set up an equation just like we would if we were solving for a side length. I'm going to use, say, my tangent of the angle, we'll say x, is equal to the opposite 20 over the adjacent 14.5. Okay, so I've got a simple trig equation here. Now the trick is going to be to get the x out of the tangent. Now to do that, what I'm going to do is, you're not going to write this work every time, but technically to cancel out this tangent here, I'm going to take the tangent inverse of both sides of the equation. Okay, the tangent inverse is going to undo the tangent. It's going to cancel it out, leaving me with just an x on the left side. And on the right side, what I have then is tangent inverse of 20 over 14.5. All right, just like always, once I get the x by itself, that's when I'll go to my calculator. All right, so getting that pulled up, we just want to plug in what we see here. Now, to get the tangent inverse, notice right above tan is tan to the -1 tangent inverse. So I'll go second, let's clear that, okay, second tangent, and then we can just go 20 divided by 14.5. Before I hit enter, I'm going to make sure I'm in degree mode. And there you go, I get 54. I'll just say 54 degrees. Okay, so not something too difficult. Draw out the situation, set up that trig ratio, and then use our inverses to solve for the angle. Okay, part B is the same idea. I want you to take a minute, pause the video, run through that question, and then hit play to check your work. All right, so let's go through B. A handicap ramp needs to rise 5 feet off the ground within a distance of 20 feet along the ground. What's the angle of elevation of the ramp? Okay, so in other words, our ramp within 20 feet needs to go up 5 feet. And we want to figure out angle of elevation. Okay, always angle going up of the ramp. Okay, once again, as far as our angle x is concerned, we've got the opposite, we've got the adjacent. Okay, that's tangent again. It won't always be tangent, but It is again in this case. So we'll say tangent of x is equal to opposite 5 over adjacent 20. Okay, again, technically we're going to take the tangent inverse of both sides, but I'm just going to rewrite this as x equals tangent inverse of 5 over 20. All right, so x is equal to second tan inverse, get out of here, 5 divided by 20. Hit enter, and I get 14 degrees. I'll say that makes sense for a handicap ramp. Don't want to be too steep. All right, there we go. All right, let's give problem 2 a shot. And this is just going to be an extension of some of the trig problems we did earlier in the semester. It says from the top of a, let's say 100, instead of 10-foot tall building, 100-foot tall building, you observe a car moving towards you. If the angle of depression of the car changes from 22 degrees to 46 degrees, how far has the car traveled? Okay, so let's draw this situation out here. We've got a building that is, we'll say, 100 feet tall. And for some reason, you're standing on top of it. Okay, from your perch, you notice a car moving towards you, and its angle of depression is changing. Here's what's happening there. So the car has a starting position, and that's going to be the smaller angle, the 22-degree angle of depression. So let's draw that in. That's going to be an angle from the horizontal, looking down at the car, of 22 degrees. Okay, and as that car draws closer to the building, yuck, but oh well, that angle is going to change. It's going to open up. It's going to get bigger. We're going to say now it's 46 degrees. And we want to use that information, okay, just the height of the building, the two angles, to make an indirect measurement and figure out, we'll call it D, how far the car is driven between those two positions. Okay, the trick for that, well, there's going to be a couple of tricks. First trick I'm going to use is that the angle of depression and elevation are always equal to each other. So as in this 46-degree angle of depression is going to be the same as the 46-degree angle of elevation here. Same thing with the 22-degree angle of depression. That's going to be the same as this 22 here. All right, and then the other trick I'm going to use to find this missing piece of a right triangle, it's not a whole side but a piece, is I'm going to figure out what just the distance from the final piece of the car is to the building. We'll call that Y. And then I'm going to figure out how far the car was initially from the building. I'm going to call that X. Then as you can see, if I use some basic geometry skills here, we could say that D, our distance we're looking for, is just equal to X minus Y. All right, what I'll do is I'll find both X and Y separately, then subtract them. They'll give me my answer. Okay, so let's do that. Let's look at the X first. That's going to be dealing with this larger triangle here made up of the 22 degrees, the side length of X, and the 100. Okay, so good old-fashioned trig. 100s are opposite side, X's are adjacent side. That's going to be tangent again. I'm going to say that tangent of 22 is equal to opposite 100 over adjacent X. Okay, to solve that, I'm going to multiply both sides of this equation by X. So I have a X tan 22 is equal to 100. And then divide both sides by tangent 22. That'll leave me with X equals 100 over tan 22. When I plug that in my calculator, I end up with a 247.5, we could say. Okay, for the y then, we're looking at the smaller triangle. Okay, utilizing the bigger angle, the 46 degrees here. So again, I'm going to say tangent, we'll say 46 is equal to opposite 100 over the adjacent y. Okay, I'm going to multiply both sides by y to get y tan 46 is equal to 100. And I'm going to divide both sides by tan 46, so that'll give me y is equal to 100 over tan 46. When I plug that in, I end up with y is equal to 96.6 feet. Okay, to finish this off then, we said d is equal to x minus y, so d will be equal to that 247.5 we just had. Okay, minus the y, 96.6. When I subtract the two of those, I get a 150.9 feet. All right, so that'll be the distance the car traveled between its first position and second position. Okay, so there's an example of an advanced trig story problem, we'll say. Basically, the approach we're going to take is to take the situation and break it down into two separate right triangles, and then we can basically do addition or subtraction with them. Okay, why don't you pause the video, give part B and part C a shot. Okay, now they're completely different situations. We're not talking about cars and buildings, but we're going to have the same kind of problem where we have to break it down into two separate right triangles and deal with them individually. All right, let's draw up problem B. So standing 100 feet from the base of a cliff. So we are 100 feet away. Okay, you sight a flagpole on top of the cliff. So we got another flagpole. You measure angles of elevation to the top and bottom of the flagpole to be 33 and 30 degrees respectively. That respectively just means 33 goes with the top, 30 goes with the bottom. Let's draw that out. So from our measurement to the top of the flagpole, we've got 33 degrees. That'll be the bigger angle. And then to the bottom, we've got 30 degrees. Again, we want to know how tall is the flagpole. Let's call that H. And then I'm going to say we have a similar approach for this problem. What I'm going to do is I'm going to find the height all the way from the bottom of the cliff to the top of the flagpole. I'm going to call that X. I'm going to find the height to the top of the cliff. We'll call that Y. You can use different letters than me, but we'll get the same thing. I know that H is going to be equal to the X minus Y once again. All right, so let's set up these trig equations for the X. For the X, I can say that tangent of 33 is equal to opposite X over adjacent 100. Now this time I can just multiply both sides by 100 and end up with just an X on the right is equal to 100 tan 33. All right, so in other words, a 64.9. And the same idea for this smaller triangle with a 30-degree angle. We have opposite y over the adjacent 100. We'll say tangent of 30 is equal to opposite y over adjacent 100. Multiply both sides by 100, we get 100 tan 30 is equal to our y. Now when I plug that in, I end up with y is equal to 57.7. All right, so x minus y will be the x, 64.9. All right, minus the y, 57.7, for a grand total of 7.2 feet for the flagpole. Okay, like we said, different situation from part A, but hopefully you realize it's the same kind of problem, just flipped on its side within a different context. Part B is the same idea, so if you haven't yet, pause the video, work through part B, and then hit play to check your answer. Alright, let's go through part C. So it says, in a plane flying at an altitude of 32,000 feet, the navigator measures a coastline at a 15-degree angle of depression. Okay, let's draw this up. So let's say I have an airplane. That's an altitude of 32,000 feet. And we measure an angle of depression to a coastline of 15 degrees. Okay, now after flying for some time, at the same altitude, he measures the same coastline at 32 degrees. So in other words, we're going to fly for a while towards the coastline. We'll say this is the new position of our plane. And now when I measure that angle of depression, it's opened up to 32 degrees. And I'm going to use that information to figure out the distance between these two plane pictures. Okay, the distance the plane flew from the first time I measured the angle to the second time. Okay, again, this is the same kind of problem we just looked at, except for kind of flipped upside down from the first case. What I can do is I can find the distance from the plane's starting position to above the coastline. We'll call that x. And then I'm going to find the distance from the plane's current position to above the coastline. We'll call that y. And then once again, like we've done, we'll say that d, the difference here, is just equal to x minus y. Okay, now we don't quite have right triangles here. There's a couple ways we can mix things around, okay, to make the pictures look a little nicer. I could pull my angles of depression down into the angles of elevation. That might help. But the trick I'm going to do for this one is I'm going to take this 32,000 feet and move it to the other side of the picture. So here's my right angle. And then to solve for the x, I'll use this 15 degrees. And that'll be with the larger triangle. Okay, we've got our 15, opposite side will be 32,000, adjacent's our x. So we got tangent once again, we'll go tangent of 15 is equal to 32,000 over x. Alright, cross multiply, divide, they'll give me x equals 32,000 over tan 15. When I plug that in, I get a 11942, round to the whole number, we'll just say 6. And same idea for the smaller triangle, using the 32 degrees this time. We'll just say that tangent 32 is equal to the opposite 32,000 over the adjacent, the y. Cross multiply, divide, we end up with y is equal to 32,000 over tangent 32. In other words, y is equal to 51210 when I plug that in. All right, so d equals x minus y. The x is the 119,426, okay, minus the y, 5,121, and I lied, I'm going to write this to a 1. 1. When I subtract the two of those, I get a 68215, okay, feet for a total.